Again, guys, this is part 2. Okay, so yeah, okay, guys, all right, yes, we are back here, guys. Apologies, in between our the setup broke, and yeah, so we have to create another part here. So we have created one more part, just like how in between one time happened, no, in Q's videos. We have created part A and part B. So for this session also we will create part A and part B, guys. Alright, so don't worry, we'll continue. So we were here into our Prim's algorithm graphs data structure. Okay, so we are gonna talk about how to calculate or how to apply Prim's algorithm into this graph which you have right now. So the requirement is we need a priority queue of type minimum heap. We are going to create a visited array and we are going to create an answer vector. We don't have to create an answer vector explicitly, but we can do that if I want to. And you want sum, okay, which is gonna be literally set to 0 in the beginning, okay, and later on we will see this, what we can do. We will start from, you can start basically from any node, guys, but let me just create all the requirements here. Actually, let us create it properly. So here we have our priority queue. This is our priority queue, and in this priority queue what we are going to store is, we are going to store the weight, comma, we are going to store the node, comma, the parent. This is going to be the format which we will be using: weight, node, and parent. What is the weight of the edge, where we are going, towards which node we are going, and from where we are coming, that is parent. Okay, all right. The very first thing that we are going to do here is gonna be add up, or let me create a priority queue, not right here but here, so that you guys can understand in a much better way. Okay, here I'll write weight, node, and the parent. Weight, node, and the parent. Okay, guys, so here the very first thing, we are starting from 0. So we are starting from 0. From 0 to 0, what is the weight of the edge? 0. This is the weight, comma, till where we are going? We are going towards 0. And from where we are coming, because 0 doesn't have a parent node, we are going to take parent as -1. Understood this, guys? Is this clear? This is your priority queue. Now we will create a visited vector, a visited array or a visited vector, where we will write all our nodes: 0, 1, 2, 3, 4. Okay, guys, so we have our visited vector. So this is visited vector, and then we have our answer, which is, let's say, minimum spanning tree. We have our answer here, which we will be dealing with very shortly. So here by default in the visited vector we will put everything as 0, 0, 0, 0, 0, and later on we will make them as 1 for true and 0 for false, which means that that particular node has been visited. Alright, guys, yep. So in this case, these are the three things, and sum, later on sum is equals to, right now it is set to 0. Understood? Right now it is set to 0. These are the requirements which you need to create. Now, very first thing, what you need to do is, very first thing, here you can start from any particular node, but here I am starting with the first node 0, and because I am starting with the first node 0, I am gonna take it as weight equals to 0, because there is no edge between 0 to 0 or before 0 towards 0. There is no weight of the edge because there is no edge itself. Then where we are going towards? We are going towards 0, and from where we are coming? -1. When the parent becomes -1, that becomes the starting node. What we will do is, we will pop this out, and what we will do is, we will pop this out and we will mark this as visited. That means 0 has been visited now. We are standing at 0, and this node doesn't have to be added. Whenever you are dealing with MSTs, the very first thing what you will do is, whenever you pop anything, you will note it down right here like this, and you will take this these two coordinates, and that two coordinate you will add right here, and whatever is the sum, weight will be added to the sum. Like this you will do. But the catch here is that because this is the very first node, because we are just starting with 0, we are not going to add or consider that into the MST. Remember this, guys, we are not going to consider this first node or first coordinates in the MST, because logically you think there is no such node called as -1. I hope so that this is very much clear. So first you pop out and mark 0 as visited. Now you have visited 0, that means you are standing at 0, and when you are standing at 0, look at its adjacency list, look at its adjacent neighbor. You can create an adjacency list, because of course how you will refer that you have the adjacent neighbors. Of course you will need a adjacency list, so you can add adjacency list also in the required items, guys. So here you are standing at 0 and you see who is your neighbor. 1 is your neighbor, this side 1 is your neighbor, and 2 is your neighbor. 1 is your neighbor and 2 is your neighbor, right? Now you see, you can go towards 1 and you can go towards 2. Let's consider 1 first. Is 1 visited? No, 1 is not visited. So you found a new path that I can go towards 1. As soon as you found the new path, guys, what you will do? You will add that path into this priority queue, just like how we did in Dijkstra's algorithm. Okay, so I'll put, what is the weight? Weight is 2. So weight is 2, comma, where we are going towards, from 0 to 1 we are going towards, and from where we are coming from 0. So this is the new path which we have found right now. So this is 0 and close. So this is the new path we have found. Guys, at this point of time, you thought that you are going towards it, you found a new path. That doesn't mean that you have to mark this as visited. No, do not mark this as visited until and unless you pop it out. Right now I have not popped it out, I have just pushed, I have just added the new path into the priority queue. So when you are pushing any element, you don't have to pop it, or you don't have to mark it as visited. When you will mark it as visited? Once it is popped. I hope so that this is very much clear to what I am trying to explain you. You just found the new path, you have not visited it yet. Once you will visit it, then you will mark it as visited, and once you visit it, you will pop it out. Right now I have not popped it out, right now I have not visited, so I am not going to mark visited and nothing will happen. You just pushed the visible path that I can visit here also. Then you will go to the next neighbor. You see that you can go towards 1 which you have included, but now you can go towards 2 also, right? And when you saw this, you saw another visible path that I can go towards 2. So going towards 2, what is the weight? Weight is 1. So you will add here 1, comma, where are you going towards? You are going towards 2, comma, where are you coming from? 0. So another path you have got. So 2 paths you have got from 0, 0 to 2 or 1, and then their weights. These are the 2 visible paths, but you will not mark them as visited yet. Why? Because you have not visited. You have just seen that these are the 2 possible paths which I can go towards, but you have not visited yet. And for that reason, we will be checking it out. Okay, guys. Now, so in this case, next what will happen is, right now this is your first iteration over. First iteration over, as soon as you push all the visible paths, your first iteration gets over. Now next what you need to do, you see the minimum heap priority queue will pop out, will delete the smallest distance first, right? And what do you see the smallest distance is? This one, 1, 2, 0. This is the weight, this is the node, and this is from where you are coming from. So this is the node. So you are basically, if you are popping this out, you are visiting this 2, and when you are visiting this 2, you have to mark it as visited. So yes, I said that I have visited 2. Now you are standing at 0. Wait, once you pop it out, you note it 1, 2, 0. Okay, this you have popped it out. First one you will never take into consideration, but from second onwards you will take into the consideration whichever is minimum, that will be popped out prominently. This was minimum right now, so we took it, we popped it out, we marked it as visited, and you see this is our next, or you can say first, this is our first coordinate or first edge we have got. That means 2 to 0. 2 to 0 is possibly our first MST edge here. Okay, so I'll write here 2, 0. I've noted it down. Alright guys, I've noted it down. Then what is its weight? Its weight is 1. Add that into the sum, plus 1. Alright guys, I hope so that this is very much clear. This is done. Now you are standing at 2, because you visited it, you are standing at 2. The same thing you will repeat it now, where you are standing at 2 right here, from where you can see, where all places you can see towards 0, you can see towards 1, you can see towards 4, you can see towards 3. So there are 4 things that you can see, 0, 1, 4, 3. There are 4 available paths guys. How many paths are there? There are 4 available paths. Now, which path you will go? If you go towards 0, 0 is already visited, so you will never go to 0 again. Now, what is the next possible path? 1. Is 1 visited? No, 1 is not visited yet. So yes, you can see a possible visiting path. So we can add that. So you are going towards 1, 1 is the weight, and coming from 2. So 1, 1, 2 is the possible path. I hope so that this is very much clear. This path is added. Now let's say we'll add this one. So you are going towards 4, weight is 2. So 2, 4, 2. So 2, 4 and coming from 2. Then you can go towards this path also. This path also, right? You can go towards this path also. So you are going towards 3 with weight 2. So 2, 3, coming from 2. I hope so that this is very much clear. These 3 paths are done. Your next iteration is over and you have already found 1 coordinate. Understood this guys? Now the next iteration starts again and you see that we need to pop out the smallest distance here. Which one is the smallest distance? We have 1, 1, 2. Of course, pop it out 1, 1, 2 and mark it as visited. Mark it as visited, and you saw that you popped 1, 1, 2. So this is your next coordinate. This is your next coordinate 1, 2, 1, 2, 1, 2. This is our next edge we have already got. So 1, 2 is our next edge. This is your MST getting formed in this case guys. And what is its weight? Weight is 1. Add 1. I hope so that this is very much clear to all of you. Correct? Now this is done. You are standing at 1. You are standing at 1. So you will see possible places where you can go from 1 again. So you can go from 1 to 0. 0 is already visited. You can go from 1 to 2. 2 is also visited. So you will not do anything in this case here guys. You will not do anything in this case guys. I hope so that this is very much clear to all of you guys. Okay. Now you see you have found the next one. Alright. Now here this iteration is over. Next, which one you will pop out? You see that 2, 2, 2. All the weights are equal. So you will go with the next one, the node number. The node number is 1, which is the smallest. So you will pop out that. You popped out 2, 1, 0. You popped out 2, 1, 0 guys. Okay. You popped out 2, 1, 0. So when you popped out 2, 1, 0, you write 2. Okay, let's see. You write 2, 1, 0. Guys, here you see you have already visited 1. You have already visited 1. So there is no point of popping that one again. So you will not consider this case. You will not consider this case because 1 is already visited and you just popped it out from there. So this will not be considered guys. I hope so that this is very much clear to all of you. Alright. Next, what will be the next one? Of course, this will be the next one. 2, 3, 2. So you will mark 3 also as visited because now you are visiting 3. 2, 3, 2. You put it like this. This is your next coordinate. So 3, 2. 3, 2 is your next coordinate. And what is its weight? Its weight is 2. So plus 2. You are standing at 3. So you are standing at 3. You got this coordinate. That means this also is the edge in the MST. Okay. This also is the edge in the MST. Alright guys. Now you are standing at 3. So when you are standing at 3, what are the possible places you can go? You can go towards 2 and you can go towards 4. Now 2 is already visited, so you will not go towards 2 again. You will go towards 4, which is not visited in this case. And once you do that, you can add this case here, going towards 4 with the weight 1 and coming from this. So next one is 1, 4, 3 guys. I hope so that this is very much clear to all of you. And you are not going to mark 4 as visited yet because you have not visited, you have just seen the path. Now the next one, who will get out first? Of course this will get out first because this is minimum 1, 4, 3, and 1, 4, 3 you will note it down, you will mark it as visited, you will note it down here 1, 4, 3, and you see this is your next coordinate 4, 3. 4, 3 means this edge is your next edge. Alright guys, this edge is the next edge guys. And what is its weight? Its weight is 1. So plus 1. Alright guys. So now you are standing at 4. Is there any possible places you can go? Yes, you can go towards 2, but 2 is already visited. You can go towards 3, 3 is already visited. Guys, you cannot go anywhere. So this iteration gets over. Now you see what is left here. We are left with 2, 4, 2. You see, I'll pop this out at the last. 2, 4, 2, I popped it out and I wrote 2, 4, 2. But 4 is already visited, so I will not consider this case guys. And you see that the queue became empty. When the queue became empty, this came out of the function, and this is your final answer guys. This is your final answer guys. This is your answer vector. This is your answer vector. Add the sum 1, 2, 3, 4, 5. So maximum is 5. So this, out of this graph, basically this is your minimum spanning tree, 3, and this is 1 and this is 4 guys, with the weight of 1 and 2. Sum of the weights are 5. In this case 1, 2, 3, 4, 5. This is the MST of this graph. And guys, this whole logic which you see here, is the Prim's algorithm. I hope so that this is very much clear. This is the logic for Prim's algorithm. Diksha GV, sir, how many sessions will this data series include? Are you going to cover all the topics required for our placements? So you see, Diksha, actually this is going to be the end of this video. Today's live session is going to be the end of this whole series, placement live series. Very less attention is being given now because as we are increasing, this is the session number 40. Nobody is able to retain till 40. But we have done a lot of videos, we have done a lot of concepts. If you do this, this will kickstart your journey towards placements, and this is gonna be more than enough to crack some companies in this case guys. Alright, so now from the next live session, we will do only on demand concepts related to placements. And yeah, but this is, I have covered like 80%, I have covered the whole syllabus. Apart from this, if there are any extra videos coming up, I will be doing it on demand. If students are actually requiring it on demand, then I'll definitely do it on demand, but not continuously, because this is not progressing that much as we thought as it will. But I hope so that this is absolutely clear to all of you. Let's continue, Diksha. I guess you have understood what I said, and I hope so that this answered your question. Real Roll ER, 20 rupees donation. Thank you so much. Real Roll ER. Let's celebrate their 5th super on a live stream. Yes. Thank you guys. Thank you so much for all the love and support. Let's continue. So this is the logic, guys. Let us see the code very quickly and we will end up this live session. We'll wind up this session. Right, guys. So here, this is the code here, guys. I hope so that this is very much clear to everyone. And here you see that we are using here the we have created the adjacency list. So this is the vector of vector. We are creating the pair, and this is the whole. You can create your own adjacency list as well if you are not able to understand this one though, but you can create your own adjacency list. We will construct the graph from the input edges, and this is the priority queue. Now I have already done this priority queue in the Dijkstra's algorithm yesterday. So guys, this is the priority queue, and then this is the visited array. Yes, this is the visited array. Alright guys, and this is the MST edges. Finally, this is the answer vector. Now what we are doing is we have started the start node and we marked it as visited. Then we pushed the thing. We started the while loop. And then we took the topmost element, because this is a heap data structure. Automatically this minimum most element will come on the top. So we are taking the topmost and we are popping it out. Its weight is getting added into the sum, and the u and the parent is being taken, and that edges is going to get pushed back into the MST edges, and the weight is taken into consideration and that is getting added. We are going to its adjacency list, and then we are doing the same exact thing repeatedly in the while loop. Guys, this is the code for this. You can find the question onto minimum spanning tree Prim's algorithm on Coding Ninjas. There you will find this, and if you do a solution like this, you will be able to solve that question. I hope so that this is absolutely clear to all of you guys. Well, this was your Prim's algorithm in data structures and algorithms, guys, and I hope so that this is very much clear to all of you. I'm going to conclude this series because there was very less public audience retention on this, because I know a lot of videos are there and it is difficult for all of us to cover, but it's okay, that is fine. Now we will be creating the videos based on demand of students. So the more demand on a particular topic, that topic will be covered. Apart from that, we are creating our own batches on DSA. So if you would like to join us in Coders Arcade as an offline or online batch, as in crash course or a full 120 hours course, then we are up to it. So guys, follow us on all the social media, especially on Telegram, if you want to join our batches. And yeah, we will be posting our stuff onto our Telegram channel. Telegram channel's link is given in the description below. Guys, very important, Telegram channel is the most important thing here. There we post our daily videos, notes and everything, every detail on that. Anything related to placements, anything related to internships, anything related to the concepts in DSA, all the things. And you can put up your request onto that. You will find me there in the Telegram channel as an admin there, guys, and you guys can also join there. So I hope so that this is very much clear to all of you guys. That's all for this live session, guys. Thank you again so much, guys. And yeah, this is gonna be the end of this live session. If you have any doubts, please do let me know in the comment section below. And from very soon we are going to start with Java live sessions. So if you are interested in learning Java from us, definitely join our Java live stream. Understood this, guys? Like how we are coming for C++ DSA, now we will come for Java as well, guys. So stay tuned for more updates on Java. Hopefully by next week we are starting with daily Java live sessions on our channel Coders Arcade, on your beloved channel Coders Arcade. Very soon I am going to start working on our Docker video also. So if you are interested in Docker or in fact in machine learning also, please do stay tuned with our channel and stay subscribed. Do like, share and subscribe to our channel, and don't forget to press the bell icon also,
Stay tuned guys, so that you won't miss any future updates. And guys, thank you so much. Learning Java. Your name is only Learning Java. Yeah. All right. But I hope so. Thank you so much for giving me all the love and support, guys. We have come to a conclusion for this DSA placement live session, and I hope so that you have liked and loved this placement series. For more updates, stay tuned with my channel, guys. I'll be there creating videos. There are more videos on our YouTube channel. Go ahead and watch that, and I'll keep on coming on this channel for more and more such contents like DSA. I'm gonna start very soon. I'm thinking of starting the C++ placement company interview questions based off of DSA on lead code. So yeah, we will do that. We will do that on the basis of the demand and the videos, the live sessions. We can cover it slowly because there are a lot of things. Guys. So we will cover that also slowly, and I'll see you guys again very soon. I hope so that this is very much clear. This is not over yet, guys. I'm concluding this placement series, but this is not the end, guys. We will keep on coming more live with more content, and these algorithms, Chickappa YR, these algorithms we will complete slowly, and we will do all the things slowly. It will take some time, but we will finish them off. Other than that, if you feel that this is going very slow, if you want, you can join our courses also. Those courses are available both online and offline. So if you are interested in joining that, you guys can join that as well. Join our Telegram, subscribe to our Telegram channel, guys, and stay tuned there. I'll be posting all the updates over there. And guys, thank you so much for watching this live stream. I'm gonna end up this live stream, and I hope so I resolved all your queries, guys. Correct? Yep. Alright guys, thank you guys so much once again. I'll be finishing up this live stream, guys, and yep. Thank you guys so much. Take care, stay safe, stay healthy, keep learning with Coders Arcade, and that's all. This is Ashank David signing off. I'll see you guys in the next video, or maybe in another live session very soon, guys. Thank you again so much. Thank you for all the love and support that you have given me. Take care, guys, and don't forget to like, share and subscribe. Don't worry, I'm not going anywhere. I am gonna come more and more live session. This is my channel, and I will be there always. So if you have any doubts or anything, you can please comment, and you can just tell us in the social media. You have a Telegram channel. We can do a lot of stuff there. Still a lot to do. Alright guys. So guys, thank you so much. I'll be seeing you very soon again, guys, in some other live session, in some other day. Until, take care and stay healthy. Keep learning. This is Ashank David signing off, guys. I'll see you guys after some time. So guys, bye bye. Thank you so much. Take care.